So, hi everyone, welcome back to my channel. Today I am going to solve a question from the algebra, and here we are given two identities and we have to find the value of this and we have to prove, right, that a to the power 2009 plus b to the power 2009 is equal to c to the power 2009 plus d to the power 2009. This question is taken from one of the books of Olympiads, which is written by Xu Jiagu. So before I go to the solution, I would request you all to pause the video, give it a try yourself, and then you can watch the solution for the whole video. Watch the solution described by me. So guys, I think you would have given it a try yourself. Now, if you are not able to come up with a solution, then no need to worry about. I am here for you. So let's go ahead. So right now, as we can see, we have been given up two equations here basically, right? One of the equation is uh, that we have here is a plus b, sorry, just a plus b is equal to c plus d. This is one of the equation that we have been given here. And the second one is a cube plus, sorry, not cube, I'm sorry. And the second equation is a square plus b square is equal to c square plus d square, right? So uh, let's do one thing. So let's start with this equation, right? With this one, with the first one. Let's use it. So if we square both sides, right? Squaring both sides, what we can see is that if we square both the sides, then it becomes something like this. And we have c plus d whole square. Now, if we square this, it becomes a square plus b square plus 2ab is equal to c square plus d square plus 2cd. I think it's pretty straightforward till here, right? Now, if we observe one thing here, right, we can do something like this: a square plus b square. We can subtract c square plus d square from the right hand side by bringing it to the left hand side, and we will be getting this 2ab here, this 2ab here, and we will remain with 2cd on the right side. So as we can see here that a square plus b square is equal to c square plus d square, we can simply say that this is equal to 0. And now we have 2ab is equal to 2cd, which implies that ab is equal to cd. So this is one of the important information which we will use in our further equations. So I think it's pretty straightforward till here. Now let us try to calculate something like uh, let's try to find uh, some equality, right, for power 3 on a b c d. Let's try to find out an equation, right, for this. So I think if we need to make the power 3, we need this power 2 and this power 1, right? So because 2 plus 1 is 3. So we will be probably getting something in terms of 3 when we multiply these two equations, right? Which we have here right now. So let's multiply them. It will be a plus b multiplied with a square plus b square is equal to c plus d, c square plus d square. So basically these two equations will be equal because the first thing that we are multiplying are equal by this, and this is the second thing which we are multiplying is equal, right? So it turns out to be something like a cube plus uh, ab square plus b a square plus b cube. And to the right hand side we will get a similar thing. We will get cd square plus d c square plus d cube. So eventually we have something like a cube. If we just rearrange it a bit, we will get something like this to the left hand side, and c cube plus d cube and then cd c plus d on the right side. So now what we can see easily here is that we have already proved that AB is equal to CD, and we know that A plus B is equal to C plus D, right? So we can simply say that this AB, right, this term is equal to this term, right? I am basically I want to say that AP multiplied with A plus B is equal to CD multiplied with C plus D. So if we like cancel it out from both the sides, we are going to get A cube plus B cube is equal to C cube plus D cube, right? So similarly, if you go ahead, right, like this, what happens? Like you will always get a pattern, right? Suppose, what will happen? Let's try to generalize it. You will always get you will get a to the power b to the power 4 if you just multiply um, a plus b with a cube plus b cube, right? You will be able to build the powers of 4 because the power of a is 1 here and here it is 3. So if we you will get a to the power 4 plus b to the power 4 is equal to c to the power plus d to the power 4. But in order to prove it, let's have a generalized equation by which we can come to our conclusion, right? So this is our generalized equation. I am going for it. Generalized proof, I would say it rather. Generalized proof. So let's take a simple thing like a plus b, right? And take something like a to the power n minus 1 plus b to the power n minus 1. And let's take something like c plus d, c to the power n minus 1 plus d to the power n minus 1. I'm just assuming that you are already having a power, this proved, like you are having it, this is assumed to hold true for like, uh, sorry, sorry, just, sorry, I apologize for this. It was 1 second. I committed a mistake. So I should not have directly jumped to this one. I should have told you another concept first. So basically, what happens, like the way we proved here a cube plus b cube is equal to c cube plus d cube. We can prove a to the power 4 plus b to the power 4 is equal to c to the power 4 plus d to the power 4 in the very same pattern. So let's assume, right? So let me assume, let's assume that we already reached here, like a to the power n plus b to the power n minus 1 is equal to c to the power n minus 1 plus d to the power n minus 1. Now, if we multiply the very first equation that we had, a plus b, right, both the sides, and similarly, we can multiply here c plus d, c to the power n minus 1 plus d to the power n minus 1. So this is equal to this one, and this is our assumption, right? Now let's multiply it. We get here a to the power n plus a multiplied with b to the power n minus 1 plus we will get b multiplied with a to the power n minus 1 and b to the power n, right? We will get something like this. So now again we will have c to the power n plus c d to the power n minus 1 plus d c to the power n minus 1 plus d to the power n, right? This is what we have. Now if we do some rearrangement here, right? If we do some rearrangement, so we will get something like a to the power n plus b to the power n. Now we can take ab as common, a to the power n minus 2 plus b to the power n minus 2 is equal to c to the power n plus d to the power n plus c to the plus cd multiplied with c to the power n minus 2 plus d to the power n minus 2. Now the way if we are assuming that a to the power minus 1 plus b to the power n minus 1 holds equal to c to the power n minus 1 plus d to the power n minus 1, we have definitely reached it here from this n minus 2 and b to the power n minus 2. So we can again assume that this is already known to us, and hence and this AB is already equal to this CD, right? We had already proved it. So it is a general thing that a to the power n will be equal to c to the power n plus d to the power n. So basically what happens, like we can say that if a to the a plus b is equal to c plus d, and if at the very same time a square plus b square is equal to c square plus d square, then it holds true for all all n belongs to natural number, right? We can simply say this. Now if we move to the question, we can simply say that if we take n is equal to 2009, which we have, then it turns out to be a to the power 2009 plus b to the power 2009 is equal to c to the power 2009 plus d to the power 2000. So basically what happens, like whenever you get some larger powers, right, like this, what you have to do, you don't need to calculate through the last stage. Sometimes you can just solve these questions by finding out if there is some pattern which exists there or not. If there is a pattern, you can just follow it, you can try to explain the pattern, and you can reach to the final conclusion. So hope you like this video. If you really liked it, please do hit the like button and please subscribe the channel. Thank you.